Okay, so I think the recording has started now. Pause record, stop record. So I guess I'm recording right now. So um, our presentation will be on transfer, problem solving, and critical thinking. Our group members are myself, Kirsten Santos, Rogelio Jimenez, and Alvin Arana. So first of all, what is transfer? Before we start, I just want to say that transfer, the definition that was given in the textbook was when something you learn in one situation affects how you learn or perform in another situation. For example, if you're a person that does pencil drawings, you may have skills that helps you achieve the artistic goals that you want, right? So you may have skills that maybe the pressure on the pencil or the pressure on the type of paper, that type of knowledge, and the ways in which you draw lines and wireframes for your drawings. So that's a set of skills that you have beforehand, right? So you already know how to do pencil drawings. And what happens when you want to do graffiti art instead of pencil drawings? Well, what transfer says is that you use skills with your pencil with when you draw with pencil drawings, you have skills that help you to learn graffiti art. So that's another skill. So the pencil drawing would be your first skill, and your graffiti art would be a skill that would require transfer. You may need to transfer, for example, how bold a line is. That may transfer into knowledge as how much time the spray can stays on the wall, or maybe the theory of colors would help you in the graffiti art. So the transfer entails the skill that you already know would help you to learn a new skill. So all of this happens in the background. For example, you don't necessarily think about the drawing that you're doing in graffiti art when as something that may look like a pencil drawing, but you just think subconsciously of what you are doing, and art is something that requires that, right? So the main things are, for example, though those that I mentioned would be the wireframing and the color theory, but other smaller skills you can transfer. A number of skills you can transfer. More than one skills can be transferred to a new skill, right? So what are the types of transfer? So positive transfer, when learning in one situation affects learning or performance in another situation, right? That is positive transfer. For example, you may use your knowledge of velocity you may transfer that knowledge onto estimating distances when you drive, maybe looking at a map. So that is positive transfer. And negative transfer is when something learned in one situation hinders a person's ability to learn or perform in a second situation. So for example, this may not come as a surprise, but sometimes students do make mistakes when they're doing mathematics, when they're just learning the root is the inverse of a square. So they already know this fact, right? So negative transfer entails then them transferring that knowledge onto something that has almost nothing to do with it. So for example, finding the distance between 2 points. And as we may know that squaring both sides does not lead to the correct answer. The correct answer would not be A plus B. These do not cancel out. And that would be an example of negative transfer. Another more simpler term for negative transfer would be maybe a misunderstanding or a misconception that students may have when they learn. So that's negative transfer. Vertical transfer is when a learner acquires new knowledge or skills by building on more basic information and procedures. For example, knowledge of lines and area, we may know that this is a dot is actually 0 dimensions. One dimension would lead to just a line, and two would lead to a 2 dimension, which would be area. And transferring that knowledge, vertical transfer, would use this knowledge to help you understand notions of third dimensions, for example, volume. So that's vertical transfer. So you use previous knowledge to help you go one step further into, into, into the topic. So lateral transfer, when knowledge of a first topic is helpful, but not necessarily essential to learning the second skill, right? So Pythagorean theorem is really helpful. It really does help you find distances of sides of triangles. That doesn't necessarily help you in learning trigonometric identities, but it is very helpful because sines and cosines and tangent can be explained through the SOHCAHTOA, right? So for example, the adjacent times the hypotenuse and then the opposite times the hypotenuse, that is not necessarily required for you to know these identities, but they do really help when you're trying to understand these identities. So they are kind of related, but not necessarily, you don't necessarily need to learn trigonometric identities. You can just memorize them or maybe just put them inside a calculator. And near transfer involves situations or problems that are similar in both superficial characteristics and underlying relationships. For example, when solving simultaneous equations, you can transfer that knowledge of simultaneous equations into worded problems of simultaneous equations. They are similar superficially. They are not really similar superficially, but they do have the underlying relationship, which would be the simultaneous equations. And the worded problem would just have these equations written down in words. So they're pretty similar. So that is an example of near transfer. Far transfer involves two situations that are similar in one or more underlying relationships, but different in the surface features. For example, in reading essays, all that English knowledge would help you when you go and transfer that knowledge into reading scientific papers. The reading is constant. You have to read, right? But the outcome would be that this is a more scientific paper, and this would just reading an essay could really just be an argumentative essay, but that really does help. And they are very separated. One is an English related skill, and one is a mathematics and a more academic scientific type of skill, right? So that's far transfer. And scientific specific transfer occurs when the original learning task and the transfer task overlap in some way. For example, when your knowledge of base 10 systems helps you in learning the base 20 numerical system, the Maya one, right? And before we even, maybe in primary school, before we even learned the Mayan system, we had to learn numbers. We had to learn ones, tens, maybe up to hundreds, right? So we needed, as you can see, here we learned ones, twos, threes, tens, 20s, and that specific transfer went right into how we learn Mayan numerals. So as you can see, the 0, 1, 2, the 10s and the 19s, the 15s are all beside the Mayan numerals so that we can make the link. So those are specific types of transfer. And general transfer means the original task and the transfer task are different in both content and structure. For example, and knowledge of Greek language, we may not really have knowledge of Greek language, but if you do, it does help you in in knowledge of physics equations. You may not really know what these equations mean, but you know that these characters are from the Greek language. So those are general transfers. So imagine just just looking at this equation without prior knowledge of Greek of the Greek alphabet. It would just look like scribbles. But because we kind of know how the Greek language, how the letters look, we may find something to grasp on. Maybe this, we know that this is a Greek letter. We know that this is also a Greek letter, this H as well. And those are general types of transfer. They're completely unrelated, but they both, you can use them as to understand things in a more general sense. And factors affecting transfer. So when transfer is being done, um, it needs to be motivated by something, right? So meaningful learning helps students engage in transfer. And just you can just imagine, I'm a very English based student, or I'm a very mathematics based student, and I want to transfer my mathematics onto maybe agriculture. I have no affect for agriculture, right? And that may hinder my ability to transfer my mathematical knowledge onto agriculture, right? So I may not see the connection between my 2 by 2 squares, or my area, or my multiplications. I may not see the use of it in when I go and engage in agriculture. So meaningful learning, we need to ensure that meaningful learning would be that something that I am very interested in. I can find skills that I can use to generate transfer. And thorough learning. So the way thorough learning affects transfer would be that maybe I need to do a more complex task. For example, maybe deriving an equation. But if I don't know the previous knowledge, I do not find the connection between the 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 moving of an x. I do not find the use of making the subject of making x the subject of the formula, right? So we need to know previous knowledge very thorough so that transfer is done correctly and effectively. And similar situations would affect transfer by having multiplication and maybe division and addition and subtraction. So we know that these things are interrelated. For example, multiplication entails adding things multiple times, hence multiplication. And division would be how many times a number goes into a divisor. Um, and when we see these types of similar situations in which we can explain something with another concept, transfer is being done effectively. Principles are easier Principles are easier to transfer. So when we learn principles, it's much easier to transfer that into a problem solving question. For example, if I understand motion equations as per physics, I may be able to understand and solve any motion equation. If I have that knowledge and that principle that an object in motion stays in motion unless acted upon an equal and opposite force, then I do have principles that may help me to solve other problems, and I can transfer those principles onto things like problem solving. Opportunities for practice. So if I engage in a new task and I just do it once, I may not always do transfer effectively. Even if I have everything in my possession, it may be distracted, it may be a bad day for me. And if I have multiple opportunities to practice that same new skill, I have more possibilities of transferring my old knowledge to that new skill. Time interval between the original task and the transfer task. And that also ties into opportunities for practice. So if I have more frequent opportunities to practice my new skill, I have more opportunities to engage in transfer. But if I scarcely do my new skill, that would be detrimental to my ability to do transfer on that skill. And environment encourages and expects transfer. So this ties into an effective a learning community, and as teachers we need to foster a learning community in the classroom. And whenever students maybe try to transfer or engage in negative transfer, we may need to encourage them to try again. And that environment helps students to have better opportunities and be more effective students and they use better transfer. So this section is problem solving, and I will move it on to my colleague.
Okay, good afternoon. Problem solving. So in problem solving, whenever we talk about problem solving, we're talking about the knowledge, the skills, the previous knowledge and skills that the students know, right? So whenever we are creating a program, there are three components. We have our goal, our given, as well as the operations, right? Now our goal will be what a program solution will hope to accomplish, right? Our givens are the pieces of information provided. Operations will be the actions. So for example, we have an example there which says find the value of x, right? We are given a linear equation there, which says 1 plus x equals 2, right? Our goal here is to find the value for x, right? And some students mentally will know that the value of x is 1, and some will have to work to get that value, right? So for this example, our goal was to find the value of x, and we were given 1 plus x equals 2, right? That was the given information there. So to get the value of x there, we had to transpose our 1, or subtract 1 both sides, right, to get our x equals 1. Now, in problem solving, there are two types of programs. There's a well-defined program as well as a ill-defined program. As teachers, we have to construct well-defined programs, which are the desired results that we want. For instance, if we want, in our example that we just had, we wanted our students to find the value of x, right? We had an instruction, a clear instruction there for our students. Our instruction there were find the value of x, right? Now for an ill-defined problem, let's assume that we didn't have an instruction there. We just had our linear equation, right? A 1 plus x equals 2. Or maybe we had something like y plus x equals z, right? 3 variables. So students won't know exactly what to do without an instruction, right? Some might understand what the teacher is trying to say, like maybe find the value of this variable, and some might not know what to do, right? So there's no guarantee that the goal will be achieved. Okay, theories of problem solving. Theories for problem solving. The early behaviors view, which are the trial and error learning and response hierarchies. So this early behaviors view, which is the trial and error, is where it's often observed in children, especially when they're doing jigsaw puzzles. And there's an experiment conducted by let me find the name. That's Turndrick, which was in the years 1898, which was with a cat. They placed the cat in a puzzle box, and then the cat had to find a way through, right? And there were some mechanisms there that will open the door, and so the cat had to find a way through the puzzle. And so we see this in children too when they are doing jigsaws. Even adults, sometimes when we are doing some puzzles which have like 1,000 odd pieces, right? Some pieces will look the same, right? So we do the try and error. We place one piece here, it fits, but maybe farther on we see that that piece didn't belong there. Maybe that piece belongs somewhere else. So we are doing try and error there. The information process theory. Most contemporary researchers take on information processing an approach and focus largely on specific cognitive process that contribute to a problem solving success. Our third theory there was the early cognitive view. Our early cognitive view, um, Wallace from 1926 identified four steps in problem solving, which was the preparation, incubation, inspiration, and verification. So the preparation, he said that the preparation is where defining the problem and gathering relevant information, right? So that's for preparation. Then incubation, he said that will be thinking about the problem, right? We think about the problem, how to solve this problem. Then the inspiration, we have a sudden insight into a problem solution. Verification, we check to be certain that the solution is correct. And so Hoya also proposed 4 steps too. Now these 4 steps relied heavily on conscious and control mental activities. And so these 4 steps were the understanding of the problem, which had identified the problem, unknown and unknowns. The other step he proposed was devising a plan, determining an appropriate action to take a solution to solve the problem. The third step there was carrying out the plan, executing the plan and monitoring its effectiveness. And the last step he proposed here, which is the fourth, is looking backwards, evaluating the overall effectiveness of the plan. So our cognitive factors affecting our success problem solving. So our cognitive factors affecting our success of problem solving. Next slide, please. Okay, thank you. So our first factor affecting our success of problem solving will be our working memory, the capacity, right? Working memory capacity. So the part of the memory which actives conscious thinking occurs. So if the information and mental process necessary to solve a problem is imposed too much of cognitive load, a working memory the problem can be solved, right? So um, for instance, in mathematics, we have like a bunch of formulas and theories, right? And we can remember all these formulas. So we take a pencil and a paper and we write it down. And sometimes we even type or we screenshot our formulas, right? So our memory, the capacity of our memory can hold all that information. So we try to write it down instead of trying to remember all that information. Encoding a problem. Um, so one critical factor in coding a program is determining what aspects of the problem are relevant and irrelevant to finding a solution. For instance, let's look at an example. So Mr. Santos, the next slide. So looking at this example here, we have our example which says, as I was going to St. Ives, I met a man with 7 wives. Every wife had 7 sacks. Every sack had 7 cats. Every cat had 7 kids. Kids, cats, sacks, wives. How many were going to St. Ives? So looking at this example here, how will we solve our example there? So our question there was, how many were going to St. Ives? So using encoding here, what do you think? What steps will you take to solve our problem here? Anyone would like to share? Okay, so for these questions, looking at this question, we could either go and try to solve it mathematically and try to say, well, you know, this man has 7 wives and each wife had 7 sacks, right? And then each sack had 7 cats, and then each cat had 7 kids, right? So we could try to solve this mathematically, right? Or we could also go and try to solve this using literature. For instance, we try to analyze our question there. How many were going to St. Ives, right? So we know that on our way to St. Ives, we saw a man, right? Or we met a man with 7 wives. So there we could see that we don't know if that man is going to St. Ives. We just know that on our way, we met this man, right? So there's either 2 ways to solve this. We either could go with maths, or we could either go with literature, English, right? Try to solve this question here. All right. So our third factor affecting our success of problem solving will be retrieval from long-term memory. And so, like I said before, sometimes we can memorize or remember all the information we learn, right? So we try to write this down, or maybe we have our USBs or our computers where we type this information, right? We type all this information down so we could go back and review this information. So knowledge base is a success problem solver have a more complete and better organized knowledge base. So um, our fourth our fifth factor here affecting our success of problem solving will be metacognition. Often plays a key role in problem solving success and successful problem solvers. And there are several beliefs here or for this. So our first there it will be believe that they have sufficient knowledge to solve a problem successfully. Realizing that some problems may take considerable time and effort to accomplish. Plan a general course of action. Flexibility, considering the possibility relevant of problem solving strategies and choosing appropriate ones. Monitor the process toward a solution and change strategies if necessary. So that will be our metacognitions. That will be our 5 factors affecting our problem solving, success of problem solving. So Our strategies in problem solving. There are two strategies, which are the algorithm and the heuristics. Our algorithms, they are the steps by step procedure for solving a problem. It could either be in a way of sometimes as brainstorming or flowcharts or so on, right? So for instance, looking at the example that we did on the first slide, where we had our linear equation, right? We could create an algorithm there which could help us understand or solve for our value of x. The heuristics, there are different types. For instance, talking to one self about the problem. Usually, I do this when I'm trying to solve a problem, when I'm trying to understand a problem. I usually talk to myself, right? I ask questions to myself so I could understand better these problems or these questions. Brainstorming. This is one that is mostly used by everyone. Brainstorming, we brainstorm, we even draw some spider webs there where we brainstorm our ideas, we divide our ideas. um Meaning and analysis, one breaks down a problem into two or more sub problems, right? So we break down these huge problems into smaller problems so we could be able to understand this better. Working backwards. So usually mathematics, we tend to work backwards, right? There's some different methods in mathematics where we work backwards to get our answer using a visual imaginary. Um, we use different charts. We use or we imagine the scenario how the problem is set, right? Um, Drawing an analogy. And yes, we do this in mathematics a lot. We tend to draw a lot of things there, especially when it comes to graphs or any charts here. We tend to draw the things so we can understand better. Using an external representation of programs components. It's similar to our previous drawing and visual aids, where we create diagrams, we list the problem's components, or we join down potential and variables to the solutions, right? Okay, facilitating transfer and problem solving in instructional settings. So when a student finish school, they really apply these concepts or procedures what they learn in school, right? So facilitating transfer and problem solving in instructional settings. Okay, students should learn information meaningfully and truly. Students should also learn problem solving strategies in a meaningful manner, discover activities and exploit instructional play key roles in the problem solving skills. Students should have a mental set of transfer. Some prerequisite skills have been practiced until they have learned to automatically like do these skills, especially in English, where the teacher will ask students like to do several summaries from stories, right, or articles until they could master this skill. Students should have experience identifying problems for themselves. Um, in maths, especially there or any other subject, students need to have experience. After a while of practicing, they gain this experience where they identify the problem and try to solve it on their own, right? Minimize negative transfer. Difference between two ideas should be emphasized. Instructional in general problem solving skills can be helpful. Students should learn strategies for defining ill-defined problems, right? So, like I said before, ill-defined programs will be the ones that are too ambiguous, right? The ones that there's no guarantee that students will be able to come to a solution. Students early attempt to solve difficult problem should be scaffolded. Digital technologies offer several good platforms for real-world like problem-solving tasks. Classroom assessments practices should include measure of transfer and problem solving. So all these facilitate the transfer and problem solving in instructional settings. Okay, critical thinking.
All right. Good afternoon, everybody. We'll be focusing on what's critical thinking. Where this presentation will be broken down into five different slides. First, we start off on what is critical thinking, the forms of critical thinking, the nature, the development, and last but not least, the fostering of critical thinking. So let us start off with what is critical thinking. Okay, so we must understand that critical thinking is the evaluation of this accuracy, the credibility, and the worth of this information and the lines of reasoning that is found from this individuals. So critical thinking is not only reflective, but it's logical and evidence-based, where these individuals will be thinking outside the box. They'll be thinking on whether how this reflects on them. Is this logical, or are they have any evidence that will back up their thoughts? So this has a purposeful quality to it, where these learners actually think critically in order to achieve a particular goal. As one of my colleagues had mentioned before, that you start off with a goal. So that's about it for what is critical thinking. So then we have the forms of critical thinking, where these forms are actually four of them, where we find the verbal reasoning, the argument analysis, the probabilistic reasoning, and the hypothesis testing, where all of these forms are actually based on a specific aspect. So if we look at verbal reasoning, so these individuals will be having their own a way of actually expressing themselves. So we have the oral language, the written language, where we will be able to understand and evaluate if these individuals are using these persuasive techniques. Now, for the argument analysis, as you can see, it might be found within the verbal reasoning where we will be discriminating between these reasons that actually do or may not support a conclusion. In the probabilistic area, we might see that we will be determining the likelihood and uncertainties associated with these various events. So we will be actually seeing if this would be whether happening or not happening on these events that these individuals might be presenting. Now, for the hypothesis testing, we will be judging the value of data and the research that these results in the terms of the methods used to obtain them and their potential relevance to certain conclusions. We will be seeing if this thinking actually refers back to a certain conclusion, seeing if it whether coincides or not. Okay, for the nature of this critical thinking, we have three different areas. We will focus on writing. You know, in writing, it actually will be involving reading first. Like, how can you start something without reading any background on it? So you might have to be reading at first for you to create something from the scratch. So why do we read? We read, of course, because reading the first draft of a persuasive essay to look for errors in logic, reasoning, or for other opinions that haven't been sufficiently justified. As mentioned, you cannot start something from scratch without having any background of it. In science, it might involve revising existing theories or beliefs that to account for new evidence. And that's true because in science, we might see that everything has past theories or beliefs for what we might want to extend the knowledge on from today. In history, it's almost the same. History involves drawing inferences from historical documents that have already passed, trying to decide whether these things actually happen or not. So in critical thinking, we will be able to use all of this to break down on what we might want to write today. Okay, for the development of this critical thinking, we actually know that critical thinking is not actually found like just like that. No, this critical thinking will be emerging throughout our life. We cannot just like you can't just say, oh, I'm smart. No, critical thinking has this process. It has this process for you to develop a huge mentality of thinking outside the box. You need time for this. It actually doesn't happen right away. So as time emerges gradually over the course of childhood and adolescence, the critical thinking skills will be emerging as well. So on average, we can see that all of these critical thinkers are open-minded. They enjoy these challenges that can emotionally motivate them. They can handle this idea that what might be correct or what might be wrong on a specific topic that they may encounter themselves. So this is a very critical point for us to look at, that critical thinking does not happen just like that. It will be emerging over time, and most likely in the age of childhood and adolescence. Okay, last but not least, how do we foster critical thinking? You know, as I mentioned before, critical thinking just doesn't happen just like that. For you to foster this critical thinking, for you to motivate someone to actually think outside the box will take all of these points that I have here. We start with encourage some intellectual skepticism. What do I mean by that? You need to encourage these individuals. Encourage them. Don't let them be like not wanting to participate. Go out, encourage them, please ask them, let them participate, or even model critical thinking. You know, when people see you like a model, they want to follow. So you as a teacher in the classroom, encourage them, show them how to think critically, think outside the box. By doing this, you can actually give these students opportunities to practice it. Why? Because they have already saw it. They've seen it with you. You're the model. You encourage them, be a model, give them opportunities. But then, what if you don't want to be part of this? Okay, you can make them do debates. Let them do debates within them. Let them foster this critical thinking by themselves. How can we do this? In English, we might see that we encounter ourselves with debates. Debates is a very, very, very good technique and a way to foster this critical thinking by themselves. So let them be debating on controversial issues that may have several perspectives, and then ask them to take this perspective in their own way. Let them think for themselves without the aid of the teacher. By this way, you might help these students to understand that the critical thinking involves considerable mental effort, but that it's essential when one is deliberating about important issues. As a teacher, it is great for us to follow these steps, motivate them, encourage them, be a model, give them the opportunities, and let them do it by themselves. So that's all for critical thinking.
All right, so the information we presented here most of it is in human learning. This is a textbook that was given to us from our by our lecturer for the completion of psychology of learning. Right. So that's the textbook that we use for this information. We've also compiled a handout, and through this link, you can obtain the handout of a summary of what we have done, what we have presented. I'll be posting this link into the chat, and you guys can download that link, download that file, and it's a PDF file, and you guys can download it and maybe review on some of the things we presented today. And before we end this session, I'd like to ask if you guys have any questions on any of the slides we presented today. It could be transfer, it could be problem solving, and it could be critical thinking. So ask away, and we are while we're still here before the session starts. Any questions? See how many of you guys are still in the right. So the chat. Okay, thank you for that. Thank you for that, Ms. Anka. Any other questions? No questions. We're looking for questions. Thank you, Mr. Clyde. Yeah. So well, the presentation is over, and you guys can leave if you want. While just recap a little bit of what we did. We did transfer, we did critical thinking, and we did problem solving. Transfer entails there are very different types of transfer: general transfer, specific transfer, near transfer, and there are factors affecting transfer. Right. So transfer doesn't always happen automatically. There are things that we need to foster. We need to foster before transfer occurs. Right. So. But what if we have a diversity of learning? Okay, that's a good question. What if we have a diversity of learning? I think you referred to a diversity of learners. Is that what you referred to? The presentation was mainly based on mathematics. The diversity. Okay, a diversity of learners. So maybe visual learners. Visual learners and auditory learners. Transfer would well, transfer can we can answer you with transfer. Let's see if we can answer you with problem solving. Based on the question, a diversity of learners would entail auditory learners and visual learners, and that would lie into givens and operations. Operations would lie in visually showing maybe a flow chart of steps that we need to take, and givens would be visual representations of the problem. For example, if maybe a question shows two cars in a race, which car reaches the finish line first. So that would lie into given. So you would have to visually show two cars in a race, and maybe even show the equations on a very big slide, and maybe color them in different colors depending on the variables. Right, and operations, the operations would be the visual operations given the flow charts, right? So let's see if we can find something else that we can answer that with.
Well, yes, actually we do. Um, if we can refer back to,
Critical thinking, right?
yes,
Is that forms of critical thinking?
okay, no, in fostering critical thinking. So we actually know that yes, there might exist this diversity of learners where not all learners will have the same, let's say, capacity to learn fast. So this is where this fostering comes. Why? Because we actually encourage them. We will be uh, encourage them to take this step of thinking, like let them think for themselves, let them open this need and want to learn. So by doing this, we will not only be encouraging, but as I had mentioned, we would be allowing them the opportunities for them to actually think by themselves. Between their colleagues, they will have this opportunity to uh, not only get this critical thinking, but to actually be encouraged to do it by themselves. So yes, they might exist this diversity, but with the encouragement and the modeling from the teacher, it would actually be easy for us to make them think.
Right. I hope that those two explanations kind of um, grasp the nature of your question, and I hope they answered them correctly. Yep. Any other questions for anybody? Right. So we recapped on cognitive factors. We did a little ways of encoding, a little activity, and yeah, those are yeah. All of this will be in the handout. Right. So I'm guessing there's no questions, right? So I'll end the recording here. Um, After this, we can maybe keep talking about what we learned, right?